Okay guys, so what we're doing today is factoring by greatest common factor. We're actually, for the video, going to skip the first page because it's really more of what the GCF comes from. We're going to go ahead and go to the second page, which is the factoring. Okay, so I'm going to show you. We did something like this last week, where we distributed by multiplication. So factoring is going to take this product and rewrite it as a multiplication. And so that's what the definition of factoring is it's rewriting an expression as a multiplication problem. Because in a multiplication problem, the things that multiply are called factors, and the answer is called the product. The first type of factoring we're going to do is factoring by using the greatest common factor. The greatest common factor of the coefficients and in the constant is the biggest number that divides evenly into all the coefficients and constant of an expression. So if we had 28, 24, and 14. Okay, so you don't have to look at all of the factors of all three of those numbers. You just have to look at the factors of 14, because the greatest common factor is not going to be bigger than the smallest number. So the numbers that go into 14 evenly are 1, 2, 7, and 14. The biggest one of those that go into all three terms here is 2. So the greatest common factor of those three numbers is 2. The greatest common factor of variables it's the same kind of thing. It's the most variables that is in all terms. Okay, so if we're talking about x to the 5th, x cubed, and x to the 7th. X to the 5th has 5 x's, but x cubed doesn't. It only has 3. X to the 7th has 7, but the other two don't have that many. All three of them have 3 or more x's in it, so the greatest common factor of these variables is x cubed. So the hint on that is to look for the smallest exponent. Okay, so the steps for factoring by the greatest common factor is you got to first find the greatest common factor, and then we're going to divide all the way across by the GCF. Now when we distributed last week, we added the exponents on the variables. This time we're going to subtract the exponents on the variables. And then we're going to write the answer as a multiplication problem. And it's going to look like this. The GCF, and then in parentheses is what's left after you divide. Okay, so let's look at the first example, 1a. So the first thing I do is I look at the coefficients, 27 and 18. I determine what the biggest number that'll go into those evenly is, and it's 9. And then I look at the variables. That term has 2 y's, but that one only has 1. So the greatest common factor is y. Now my answer is 9y times what's left. And the way I'm going to work that is I'm going to divide left to right. 27 divided by 9 is 3. And when I divide those variables, 2 minus 1 is 1. Next term, 18 divided by 9 is 2. And when I subtract those, 1 minus 1 means that there's 0 y's left. And that's my answer. You can always check by redistributing to see if you get 27y squared plus 18y. Next example. Okay, so the first thing I'm going to look at are the coefficients, the 15 and 3. The biggest number that will go into both of those is 3. The first term has a w, but the second term doesn't, so w cannot be part of the greatest common factor. The second term has a p, but the first one doesn't, so p can't be part of the greatest common factor. That means 3 is the only thing that is the greatest common factor. So I'm going to divide left to right to find out what's left. 15 divided by 3 is 5. Bring down the w. Negative 3 divided by 3 is negative 1. Bring down the p. And one thing you can remember is you don't have to have that understood 1. You can put it, but you don't have to have it. And there's the answer. C. I'm going to look at the 15 and 25 first. 5 can go into both of those. And then my greatest common factor of the variables, look for the smallest exponent, it's just going to be x. So 5x. Divide left to right. 15 divided by 5 is 3. 1 minus 1 means there's not an x that comes down. 25 divided by 5 is 5. 2 minus 1 means there's 1x that comes down. So if you need that exponent there, you can. Okay. D, I have 3 terms here, so the greatest common factor has to be common among all 3 terms. The biggest number that will go into 14, 18, and 8 is 2. And the most x's I can take out all the way across is just 1x. So 2x is my greatest common factor. Divide left to right to find out what is left in the parentheses. 14 divided by 2 is 7. Dividing those x's means I subtract the exponents. 3 minus 1 is 1. Next term, 18 divided by 2 is 9. 2 minus 1 leaves me an x down here. Oh, sorry. On this first one, 3 minus 1 is 2, so that's a 7x squared. And then the last term, negative 8 divided by 2 is negative 4, and 1 minus 1 leaves me no x's on that last bit. I've got to switch and go to the second page here to do the last 2 examples. E, it looks a little more confusing because you have an A and a D in the same problem, but it's worked the same way. Between 15 and 30, 15 is the greatest common factor. The most A's I have in both terms is an A. The most D's I have in both terms is a D. So 15 AD is my greatest common factor. Divide left to right. 15 divided by 15 is 1. When I subtract the exponents on the A's, I don't have an A coming down. When I subtract the exponents on the D's, I don't have a D coming down. Since there's not a variable, this 1 is not understood. It is 1, so you cannot drop it off. Next term, 30 divided by 15 is 2. On the A's, 2 minus 1 leaves me 1. On the D's, 2 minus 1 leaves me 1. And there's the answer. F, go through. I can divide everything by 8. The most P's I can take out of everything is 1 single P and 1 single R. So 8PR is my greatest common factor. Divide left to right. 8 divided by 8 is 1. 2 minus 1 leaves me a P. 2 minus 1 leaves me an R. Since there are variables, that 1 in front there is understood. So you can leave it off if you want. Negative 24 divided by 8 is negative 3. And on the P's, 1 minus 1 means that that second term doesn't have a P, but 3 minus 1 means that the second term has an R squared. 16 divided by 8 is positive 2, and the P's and the R's both are gone.